I apologize for the speed I'm going to be talking in this video because there's a lot to cover. Today I will be discussing, control volume for hydro systems discussed in Lecture 3 using the Ogallala Aquifer. A little background is this is the largest in America. It's an unconfined aquifer. Its area is 174,000 square miles, and it spans across 8 states in the Midwest. This is just a picture highlighted in red. You can see the unconfined aquifer. It holds 3 trillion gallons of water, and 32 billion gallons of water are used yearly or consumed or pumped out of the aquifer by us, meaning we are running out of water. As you can see here with the reds, the orange, and the yellows, a large portion of this aquifer is being drained, and the change in water level is decreasing anywhere from 10 to over 200 feet in the majority of places from 1950 to 2013. And this is similar to the Aral Sea, which we discussed in class in Lecture 3, where it was there was a large volume of water, and then it was slowly consumed, well, in the grand scheme of things, pretty fast, and now it is just a collection of very small seas, and that was last in 2019. So my diagram, my example to discuss this topic of hydro systems for the Ogallala Aquifer has an output of Q, an input of P, and an input of I. As you can see here, these two blue runoffs and precipitation, denoted by P and I, are positive and they recharge this aquifer. And then there's a negative outflow of Q, which is negative in the equation, meaning it is consumed and it is taken out of the Ogallala Aquifer. And this personal use is from farms and, home general uses and stuff. But the aquifer is also recharged using, its massive area of 174,000 on top of the fact that the water basin surrounding it, all of that water from the rain or the melted snow and all that flows in and slowly recharges this aquifer. This equation down here can also be written by changing ds over dt to area times change in height over change in t is equal to the negative outflow plus the precipitation plus the inflow. And using this is very important because we can then find the change in height to avoid this, massive decrease in water table for this aquifer, so the water stays, at a decent level where we can consistently use it for agricultural purposes. And this is found by using, just moving over simple variables. And we know what Q is because that's how much we use. We know how much it rains. We know the water border, and we can just use a simple hydro system to find the, the water that flows in. We can choose a change in time, and we know the area. In doing this, we can then find the change in height to avoid complete, depletion of the water. Thank you.